write each expression as a single logarithm. So we're going to be doing the same thing. We're going to be using these three log laws, and writing as a single logarithm means changing it to the simplified form, which is the one on the left-hand side. So what we have in A is we have log x plus 3 log y. Now the important thing to notice is you're probably going to see the plus thing first and be most tempted to use equation 1. But if we look carefully at equation 1 on the right side only works if you have a 1 log plus 1 log. And what we have in our question is an extra 3 in front. So the adding log law can only work if it's log plus log. And right now, we have log plus 3 log. But if we look back at our log laws, we do have a law that says if you have a number in front, you can simplify that as a single log by moving that number in front in as an exponent. So in this case, step 1, I'm going to take that 3 and move it inside the log as a y cubed. And now I have a log plus a log, so I can write this. Adding is multiplying as log xy cubed. For B, again, I have a log plus a log minus a log, but I have numbers in front. So you're going to find out when you're trying to write it as a single logarithm, the first of the 3 laws you're always going to use is that third one. Anytime you have numbers in front, you will first move them in as exponents. So in this case, the first thing I'm going to do is log x plus log, I'll move that 2 in as an exponent minus, and I'll move that 4 in as an exponent. And once you have logs adding and subtracting, we could put the first 2 together with one log law and then get a log xy squared minus a log z to the 4. And then we could put those together with another log law. I would like you to be able to, when you have a series of logs, adding and subtracting, do them all at once. So all 3 of these we're going to do all at once by saying whatever is added will be multiplied in your numerator. And whatever is subtracted will go down to your denominator. So we could do that in 2 steps, but we're going to just do it in 1. And so if I do a b.5 here, and I had log a minus log b squared minus log c to the 4 plus log d, I could combine that all together in 1 step by saying the log a and the log d are positive. So they will get put together, multiplied on the top. The log b and squared and the log c squared are subtracted. They will be put together in my denominator. And that is combining the log laws with adding and subtracting together. And it really makes life easy. You don't have to worry about doing 2 of them together first and then another 2 and then figuring them out from there. And then in part C we get a tricky one because we wanted to write as a single log. We're subtracting, but the thing that we're subtracting is just a number. The only way I can subtract and put them together is if I have logs with the same base. So what I need is I need this 3 to change to log base 2 of something. What's the something going to be? I need log 2 of something to equal 3. What number would go in here? So off to the side, you can think like this. I need log 2 of something to equal 3. What do logs mean? Well, logs, the definition of a log, this 2 is what in the exponent? The 3 is what? The blank space is what? It's going to be 8 as an answer because the 2 is your base. The 3 logs solve for exponents, and this is where we have our blank space, and now it just becomes, oh, I know that 2 cubed is 8. So if I want to change 3 to a log base 2, 3 is equal to log 2 of 8. And now I can use a log law to write this as a single logarithm because I have a log minus a log. They're both in base 2. So combining them will be 6 divided by 8, which you could reduce to 3/4 or you could leave like that. 5, 8, 11, and 18.